In this video, I'd like to give an introduction to database, just sort of some of the basic ideas and sort of intro to some of the vocabulary surrounding database. So one thing people talk about in database in terms of at least the motivation of a database is they start to make a distinction between data and information. So data is more like an individual little unit, sort of a small unit, or just little bits of pieces of information. Then information is sort of when you start to bring it together and sort of look at questions that take more than sort of one or two pieces of data, but sort of bring many pieces of data together. So this is, again, the distinction between data and information. So, like, here's an example. So data might be some student, John Smith, getting a particular grade 87 on a particular test, test 2, in a particular course, computer science 240. So that's sort of a piece of data, a score on a test. But then as we move towards information, it might be that John Smith's score on that test was 10 points higher than the average. So then this indication of the average was that we had more information, that we brought in the scores of all the students. So we're bringing together all those scores, and then how John did compared to that. So then that makes it information. Just the average alone would make it information, but comparing John to the information, to the average, sort of moving, these higher questions involving multiple pieces of data. Similarly, even if we're just saying that, Jane Jones got the highest score, again, we are relating, even though it's some sort of just one person, but knowing that it's the highest means that we've compared it. There's information about other people scoring on that test implied in there. So that's information. So one of the reasons in a database is sort of like a way to organize data. So we have all these individual pieces of data, and then we organize them in a way in such that it is sort of designed that it's easy to extract information from. So we're going to put together our data, our facts, and arrange them in a way that we can easily extract information from. And this doing this will be our database design. And then we will implement our design. We will use software that helps us extract the information. So not only are we organizing our data in a particular way, but we're using a set of software designed to help us extract information from the way we've organized our data, and that's the database management system. Okay, so we do database modeling or in general modeling. This is we look at some situation we are interested in, say, a company or a university or something like that. And there are all these facts, this big collection of facts that surround this situation. And then we start figuring out what is the convenient way to put this information together in this database. And so we're mostly going to talk about a type of database called a relational database. And it is based on this concept of entity and relationship. And so if you are modeling a situation, trying to organize your data about a certain situation, and you're moving toward this relational database, so then you are identifying your entities and their relationships, and then you refer to this as ER modeling, and then you represent your ideas about how the data should be organized in what's called an ER diagram. So entities are this collecting data that sort of belongs together, that all surrounds a particular thing. And again, we're often modeling a real world situation or the data of a real world situation. So we might have a person entity, and then we will take attributes, properties of the person, that person's name, address, phone number, age, birthday, social security number, whatever we happen to have. And if we collect all these properties together, then they will form an entity. And so then again, there's this, we're modeling. There's usually some sort of real object, a real person in the world. And then we have this database entity, we're not trying to model the person that that it somehow looks like the person or anything like that, but we are modeling the data for the person, that all this data relates to one person. So we have all this data together in our database. And if you have any background in programming, then the concept of an entity is similar to the concept of an object in programming, and especially a data object. So in programming, an object, you sort of bring together related data and related functionality. And this is more about just the data. Um, so we're bringing together the concept of an entity is bringing together the data that sort of belongs together. That's all related to the same thing, some particular person in our example. Okay. Then we have various entities that in our modeling, we've discovered different entities. So if we're doing a university, we might have a student entity, a class entity, a professor entity. And then these entities have what we call relationships, that there is information that connects them. So we have a class which meets at a particular time or something like that, covers a particular topic, does something in the curriculum. So there are properties of a class. Then we have a student, and then the student has an address and so on, but then that student may take the class. And so that is a relationship. So we have a student entity, a class entity, and then they have a relationship that student is in, a particular student is in a particular class, or a particular professor teaches a particular class. Okay. And so this idea, this sort of process of discovering how we want to model the real situation within our database, as we said before, was the ER modeling. And then when we want to sort of represent it graphically, we have an ER diagram. And so in this picture, typically, and there are variations on this, but typically we will take the entities we've identified in the previous example, our professor, our class, our student, and we represent them by a rectangle. And then we might list within the rectangle the attributes, the name of the course, the time of the course, the name of the professor's office, what have you. And then those relationships are represented by lines connecting the rectangles. And so the idea that a student takes a course will be represented by a line, and connecting the student entity to the course entity. And this line is representing that, in sort of generically, that students take courses, not that John Smith is taking computer science 152 or anything like that, but more generically, the idea that within our database, students take classes. Okay. So we have these rectangles and these lines, and sometimes there are arrows, and these diagrams can get quite fancy and have lots of rules, but the basic idea is just rectangles to represent the entities and lines between them to represent the relationships. And so here's an example of one. So we have the name of the entity up at the top of the rectangle, sort of some list. We have different types of properties. We'll talk about these things. And then we have these lines between them. And then you see this particular diagram can get fancy and has these little, sort of bubbles and arrows. And so there's the diagram notation can be sort of simple or sort of grow in complexity depending on how much you want to convey in your ER diagram. Okay. So after we've done our ER modeling and we have sort of designed our database, then we want to implement it. We want to say, okay, we want to let our system know, our database management system know, okay, here's what we've come up with. This is how we're going to model our university. We're going to have students, we're going to have professors, we're going to have classes. Um, and so then you need to sort of implement your uh, design. So you're going to start going from the model, going from the picture into an actual use a particular database management system, say Oracle or something, and then start turning these entities into actual things within the database management system. So then we start talking more particularly about, you know, things that are in a database. And so we'll talk about tables and records and fields and keys. So we want to start getting an idea of what these words mean in the context of a database. So we have the concept of a record. So for an entity, I decide I'm going to have, say, a person entity, and it has, say, a name, an address, a phone number. These are people, and I want to be able to contact. And so I have the idea of that what kind of properties I'm going to have, and then after I've done that, then I start to add the particular examples or what we'll call instances of the people. And so then when I enter all the properties, or even most of the properties, or some of the properties uh, that I want for a particular person, then this is known as a record, and we'll also sometimes call it a row when it's sort of when you spit out all the instances, you often look at them as a row. So the whole collection of these records is known as a table, but all the information about, say, a particular person is the record for that person or the row for that person. Um, it is comprised of a number of fields. So there'll be a name field. You may just have a name, or you may separate the first name from the last name. So each sort of individual property that you want, and there are lots of like overlapping names like property or attribute or field or column that are all quite similar, but you have the concept. So the field says, here are the things that are going to the data I'm going to collect for my entity. I'm going to collect a name, an address, a phone number. These are my fields. Then all the all the fields with their values for a particular person in this example constitutes a record. Then the collection of all those similar records make either a table or a file. So in a database in general, we will tend to talk about it as a table, but you'll also see it sometimes referred to as a file. So like sort of in the history uh, of organizing data, this might have been a separate piece, might have been a separate computer file from other data files, but it sort of has a correspondence to this idea of table. So in a full relational database, it may not be a separate file. It may you may import it as a file, you may export it as a file, but it's also just historically sometimes called file, but you'll also see it referred to as table. And then another name, again, there's lots of overlap in the vocabulary here. Another name for a record you'll see is, and I see this word pronounced sometimes tuple and sometimes tuple. I'll tend to say tuple. So this collection of data about sort of one of our instances. Okay. So this idea, again, on the previous slide, I was referring to it as a file, but also a table. And this is this collection of rows and columns. So the row is all the information about different instances, John Smith, Mary Jones, and so on. So different people. The columns are the different properties, the first names, the last names, the addresses, the phone numbers. And um, so we have this collection of rows and columns, and all the rows and columns for, say, a particular entity of, say, person, then makes up the table. And there's more in the database than a single table, because a table sort of corresponds to what, as we were saying before, an entity. And then we'll have to get in more detail in this, but this is just an intro. So sometimes a table corresponds to an entity, and it can be that a table corresponds to a relationship. Sometimes I need more than one table to make up my entity. Depends how I'm doing it, what I want the users of my database to have access to, and so on. Okay. So if we're going sort of in this picture of a table, if we're going across all the information related to Mary Jones, then that is the row or the record. If we're going thinking about the individual property, then we start talking about field or column. So again, in this two-dimensional picture of it, like if it were an Excel spreadsheet or something, all the phone numbers would line up in a column. So there would be a phone number field. All the phone numbers would correspond to a column, and you also see it referred to as property and attribute. So again, lots of overlapping vocabulary here. So I have the fields I identify when in my modeling. I define what fields I'm going to have, and then so that's more part of on the design side. And then when I start implementing and populating my database, that's when I start making records. So in some sense, the columns exist before the rows, because the row was when you're ready to enter data, particular data, instances of data into your database, whereas the columns, what are the properties going to be, is more from the design side. Here's the information I intend to collect. And there is a process of called normalization, which is helps you sort of organize your data. That there's lots of ideas in this concept of relational databases, of how to organize the data that will be efficient and allow you to get the information out of it, and have it not take up too much space, not be redundant, not have errors in it. And normalization is a procedure, a process by which you determine sort of like what the correct tables will be in your database. Much more on that some other time. This is just introducing the idea. Okay, so here we see an example of a table, sort of almost represented, sort of looks Excel. This might be from Access, but it looks like an Excel spreadsheet if you have some familiarity with that. So we see going across the top these sort of headers: customer ID, company, contact. these are our attributes, our properties, our fields, our columns. And then we have individual rows. So that third row, it starts off with Anton and Antonio, blah, blah. So that is a particular record. So, and in the process, again, we design and then we implement. So we had to come up with, we want a customer ID, we want a company, we want a contact. We did that first, and then we started putting in Anton and Antonio and so on. But but sometimes you might not have a database, but you may have some data, and that's motivating your idea for a database. And that's where that idea of normalization comes in, of like, I have some table looking, I didn't make a database yet. I have some of the data that I know I'm going to put in, and then you start looking at your what looks like a table before you've made the database. And then you apply this process of normalization to come up with the best, most efficient tables for your relational database. So sometimes you have something that looks like a table before you've made the actual database, and then that is the thing to which you apply your normalization to come up with the best possible tables to design your database from. Okay. And again, this is back still idea of I'm designing, I'm just figuring out what my fields, my attributes, my properties are going to be. So the person will have first name, last name. I've got to decide, are they going to have, am I going to put the first name and last name together, or am I going to separate them? It depends what I want to do with a name. Um, an address. Do I want to separate out the city, or do I just want the addresses all together as one thing? So these are decisions that we will have to make when designing a database, and those things together will make up our fields, our or attributes or properties. These are all the same idea. One of, if you have any background in programming, then these are like the properties of an object. Each individual thing is like a variable. So you have like the name of a variable and then the value of that variable. When you bring them, all those connected variables together in programming, then you have an object. So the fields are like variables, but also more like the properties of an object, because we've sort of brought them together and said they are related. Um, and then also, like in programming, you start to talk about types. So I have a first name, that's probably going to be a string, sort of the phone number. Um, am I going to write it as a number, or am I going to write it as a string? Probably consists of numbers, but do I do anything numeric to it? Do I ever add it? So those are decisions that you will make. If you are figuring out somebody's salary, that will be some kind of a number. Is it an integer number, or is it a floating point number? Is it a decimal number? All these things are part of the what we call the type. The so when we're figuring out what the field is, we will also figure out what type the field is going to be. How are we going to fill that in? What kind of data is going to go in there? So that will help us figure out, be consistent and always fill it up with the same sort of data. Another important idea that we're going to bring in this intro lecture here is the idea of a key. So I put all my uh, people together in all my instances of people, all my data about people together in my person table. And now I want to be able to pull out a particular person and get information about that person and do it quickly. And so that brings up the concept of index and key. So index is, in some sense, maybe a more generic thing, and index means that I've arranged my data in a way that I can sort of use if one of my fields is an index, then I can use that property to pick out the the record, either a unique record or a set of records, pretty quickly. So I can sort of sort the records on. I can Programming wise, I can sort of sort the data on any field, but if I've told a database management system that that field is an index, then it does some of the work sort of even before I ask it to explicitly sort on that field. It will do some setup work so that sorting on that field will be easy. So then that is referred to as like an index attribute, an index field. Then we bring in the idea of a key, and this is a related idea. And typically, we want the key to work as an index, and we often work with the idea of in a table of a primary key, and this is a key by which we can that which we choose to uniquely identify each record. So you know, it's possible if I have a large enough set of people in my company that two of them might have the same first name and last name. So I will need some property to identify sort of which, John Smith I mean. And so I will give all my employees an employee ID, and then that will be uniquely identify them. So that's one sense of the word key. Um, and so I will use that to identify them. So that'll make it the if I select it out particularly to be the main way in which I identify people, then that will make it the primary key. But it's also served. It also works as an index so that I can easily sort my records based on that field. Okay. Um, and so you can have multiple indexing. It's more than just the primary key. So I can say other fields are indexed. Um, and again, sort of one can give in a database course entire lectures just on keys and picking keys. This is just introductory. We can have the concept of a key in which to identify a record and also use it for purposes of sorting the data on. Another related idea, so I've already started to talk about the idea of primary key, the key that you choose to uniquely identify a record. So it must be unique. Each record must have a unique primary key. Um, it's possible in some tables to have like two fields work together to be a primary key. Um, it's also there's scenarios where you have multiple things you could have used as a key. Like a student might have a student ID, but might also have a social security number. So they both individually might uniquely identify the person, but you will pick one for the purposes of your database. Or you might have um, a a set of things, what you call a composite key, and use a combination of things to serve as your primary key. So there are lots of complications in keys, but basically, let's keep it simple for now. The primary key is a field that you've chosen to uniquely identify each record. You also have the concept in database of a foreign key, and that is used in the concept of a relationship. So I have the idea of a student takes a class or something like that. Then um, then that's where the foreign key can come in. Um, Or let's talk about a customer. This will be a little bit easier. A customer uh, orders has an order, and then that order has a bunch of items in it. Um, so to cement the relationship between the order and the customer, that order belongs to a particular customer, you would put the customer's ID into the order record, and that will establish the relationship. Well, the uh, the order might have its own individual order ID, but and that would be its primary key, but it can also have this idea of the foreign key, and that would be the customer's ID. So that would relate the order instance to the customer instance and form that relationship, and that order belongs to that customer. And now here's me saying all that now that so I have a customer table, and in that table, I have a primary key, the customer ID, and that uniquely identifies the customer. So that's the role of a primary key, to identify each record uniquely. Then in an order, in addition to an order ID, I might additionally, which is the primary key for the order table, I might also have a foreign key. And in that case, the customer ID would serve as a foreign key. And this establishes that relationship of which customer, this is an order of which customer. And that is our intro. So more to follow. Thanks for your attention.